Now we have entered into area in circles. And the first question we have says that we should find the areas of metal rings whose outer and inner diameters are 22 cm and 20 cm, 8.6 cm and 8.2 cm. Now, a metal ring, question number A. A metal ring should be something like this. Something like a washer. You have the outer and the inner circle. Okay. The first question says that the outer diameter is 22. That means the diameter from the distance from this place to this place. This outer diameter is 22 centimeter, while the inner diameter is 20 centimeters. This is exactly the representation of the question number A. Now, remember, this may be another way of saying find the area of the shaded portion. Like if they should shade this, the area you're finding is the area of the shaded portion. It is also the area of the ring, the metal ring. So the area of the shaded portion now, or the area of the metal ring, is the area of the outer circle minus area of inner circle, which is pi r squared minus pi r squared. So the difference now is in the value of the r in the bigger and the smaller circle. Here we have 22 all over 7 times the radius of the bigger circle is half of the diameter. Half of 22 is 11. So we have 11 squared all over 1. Now minus the same 22 all over 7 times the radius of the smaller circle now is half of the diameter, which is 10. So we have 10 squared all over 1. 11 squared is 121. 11 times 11 is 121. Correct. So we have 22 times 121 divided by 7 minus, here we have 22 times 100. 10 times 10 is 100 all over 7. Let's multiply up this. 22 times 121 is giving us 2,662, then all over 7 minus this will give us 2,200. That is 22 times 100 all over 7. Let's divide out. 662 rather, divided by 7 is giving us 180.29 minus, then 2200 divided by 7 is giving us 114.29. Now let's subtract 180.29 minus 114.29. It's giving us 66. So the area of the shaded portion of that structure or that metal ring is 66 centimeters squared. The second part of the question, that is part B, is just like the first one, where the outer diameter is 8.6 and the inner diameter is 8.2. From the same formula, 2 pi r squared minus pi r squared. We have 22 all over 7 to represent pi times half of 8.6 is 4.3. So we have 4.3 squared all over 1 minus 22 all over 7 times half of 8.1 is half of 8.2 is 4.1. So we have 4.1 squared all over 1. You can use our calculator now. First of all, let's find 4.3 squared. 4.3 times 4.3. Giving us, so we are going to have 22 times 18.49. Let's multiply it 22 and get, so this is all over 7. And when I have multiplied this with 22, I got 406.78 all over 7 minus, let's do the same thing here, 4.1 times 4.1, 4.1 times 4.1, then times 22. In this case, it's giving me, okay, let's have it 22 times, let's break it down first. 4.1 times 4.1 is giving me 16.81 all over 7. Okay, when I multiply it to 22, it will give me 369.82 all over 7. So let's divide by 7. 406.78 divided by 7. It's giving me 48.1. 48.1 minus 369.82 divided by 7 is giving me 42.8. So if we subtract now, whatever it gives us is the answer to question number B. So we have 48.1 minus 42.8, giving me 5.3 centimeters squared. If the area of a sector of a circle whose radius is 40 cm is 77 cm squared, we should find the angle of the sector. First of all, the area of a sector of a circle is given by theta all over 360 times the area of the circle of which the sector is part of, which is pi r squared. This theta is exactly the angle the question is asking us for. Now let's go ahead. Theta all over 360 times pi is 22 all over 7, the approximated value of pi, times, they say that the radius of the circle is 14. So we have 14 squared all over 1. Remember, they say that the area is 77. So whatever we get here, we equate it to 77. So with this now, we can find the value of our theta. So let's have theta times 22. I'm multiplying the numerators together. Times, let's find 14 squared. 14 times 14, giving me 196. Then all over, let's multiply 360 and 7. 360 times 7. It's giving me 2,520. and it's going to be equal to 77 all over 1. You can cross multiply here. If you cross multiply, you're going to find out that theta times 22. First of all, let's multiply 22 and 196. 196 times 22. So we have theta times 4312. 4312 is what I got by multiplying 22 and 196. Will now be equal to, let's multiply 77 and 2520. 77 times 2520 is giving me 194040. So if you now divide both sides by 4312, you're going to be left with only theta here, and it will be equal to 194040 all over 43112. If you divide out 43112, it's going to give you that theta has a value of 45 degrees. And that answers that question, the angle of the sector of a circle whose radius is 14 cm and the area of the circle is 77 cm squared. Now we should find the area of the sector of a circle whose radius is 14 cm and the angle of the sector is 300 degrees. The area of the sector of a circle, we get it by theta over 360 times the area of the circle. So we have theta divided by 360 times pi r squared. That is the formula for finding the area of the sector of a circle. And this is giving us theta all over 360. Now theta has been given a value. They say that the angle of the sector is 300. That means instead of theta, let's use 300 here. Times theta is 22 all over 7. The approximated value of theta, not the exact value of theta. The exact value of theta is beyond this level. Times the radius of the circle, they said, is 14. So we have 14 squared all over 1. If you finish multiplying out this and dividing, we are going to get the value for the area of that sector. So what we're going to have now is this. 300 times 22. First of all, let's find 14 squared. 14 times 14 is giving us 196. Multiply it to 22. It's giving us this value. Multiply it to 300. So in the numerator, we have 129 3600. 123 1,293,600 all over 2520. I could remember when we were small, we know the value of 360 times 7 offhand. We don't need to create the calculator. But let me confirm. 360 times 7. Yes, 2520. I'm correct. I could remember. I have not spoiled that memory with Gary and egusi soup. So we have 1,293,600 divided by 2520. It's giving us 513.333. 513.33 reoccurring. So let's stop at the second 3 centimeter squared. So this is the value of the area of the sector of that circle. The equation gave us information about it. Find the radius of the circle whose occurred twice, no problem. Just take only one. Whose sector area is 4,620 meters squared and has an angle of 180 8 degrees. As long as it is a sector of a circle. The formula for finding its area is theta all over 360 times pi r squared. So in this case now, we have to find the radius, whose sector area is, whatever we get here should be equated to 4620. Then the angle of the sector is 108. So we have 108 all over 360 times pi is 22 all over 7. The approximated value of pi. R squared all over 1 is equal to 4620. Let's multiply out the whole numerators together. 108 times 22. 108 times 22 is giving us, then times r is giving us 2376 r squared. I multiply this and this, gave me 2376. When you multiply it to r squared, to give you 2376 r squared is equal to 4620 all over 1. And this is going to be all over, multiply this and this, is going to give you 2520. I know that value. Now if you cross multiply here, you're going to have that 2376 r squared times 1 will give you 2376 r squared. Will now be equal to 4620 times 2520. So multiply out this. 4620 times 2520 is giving me 1164 2400 2400. That is 2376 r squared. Divide both sides by 2376. You'll be left with r squared here. And in the right hand side, we have 1164 2400 divided by 2376. So divide out, divided by 2376. What I could get here is 4900. That is the value of r squared. Now you have to take the square root of both sides. The square root of r squared will leave you with r. Then you find the square root of 4900. You can see, use a calculator. Square root of 4900. It's giving me 70. That means r is 70 meters long. And that is the end of that question. Question number 5 says we should find the area of the shaded portion of the figure below. This shaded portion, there is no parameter or formula to find its area. But the only way we can find its area is by finding the area of the complete square. You know that this is a square. If this side is 7 cm and this side is 7 cm, that means this is a square. Find the area of the square and subtract the area of the sector that has angle of 90 from it. Whatever it gives you is the area of the shaded portion. Area of shaded portion will be equal to area of square minus area of sector. So area of the square is 7 times 7, which is 49. Then if you subtract theta over 360, times pi r squared. From it, you get the area of the shaded portion. So we have 49, that is 7 times 7, minus theta is 90 degrees. So we have 90 all over 360 times 22 all over 7 is the value of pi. The circle of which this sector is part of has radius of 7 cm. So we have 7 squared all over 1. Let's multiply. 7 times 7 is 49. So we have 49 times 22 times 90. It's giving me, so we have 49 minus, in the numerator we are having 97020. Remember, 360 times 7 is giving us 2520. So divide this by 2520. Divided by 2520. It's giving me, let's continue here, 49 minus 38.5. Subtract that, 49 minus 38.5. Giving me 10.5. So 10.5 centimeters squared is the area of the shaded portion of the figure that the information was given to us. And that is the end of that question. Now they say we should calculate the area of the shaded portion of the figure. The area of the shaded portion of this figure can only be calculated by calculating the area of the sector, because this is a sector of a circle whose angle is 90 degrees, and subtracting it from the area of this triangle, which is a right-angled triangle. So area of shaded portion, will be equal to area of sector minus area of triangle. So let's start from area of sector. Area of sector can be calculated from this formula, theta over 360 times pi r squared. Then minus area of triangle. The area of this triangle from the second formula for finding area of triangle is going to be half the sum of, half the product of this side that created this angle. 5 times 5. Then times sine of the angle the two sides made, which is 90 degrees. Okay? This theta, the angle of the sector is 90 degrees. (22 all over 7) times r, the radius of the circle of which this sector is part of is 5 centimeters. So we have 5 squared. Minus 5 times 5 is 25. So we have 25 sine 90. 25 times sine 90 all over 2. This fraction means 1 all over 4. 90 divided by 360 will give you 1 all over 4 times 22 all over 7. 5 times 5 is 25 all over 1. Permit me to cut off this. x-axis triangle. Okay? Then minus, let's find sine 90 degrees from our 4-figure table. Sine 90 degrees is 1. You cannot find it here. But sine 89, which is closest to sine 90, is already having the value of 1. So we have 1 as the value of sine 90 times 25 to give us 25 all over 2. So let's multiply out the numerators and denominators here. 22 times 25. 22 times 25 times 1 is giving us 550 divided by 4 times 7 is 28. Then minus 25 all over 2. Let's divide out. 550 divided by 28 is giving me 19.62643. I rounded it up to 3 decimal places. The second fraction, 25 divided by 2, is giving me 12.5. So let's subtract. 19.643 minus 12.5 is giving me 7.143. And that is the area of the shaded portion of that structure or that figure, which the question has given us information about. The next question, number 7, said I should find the area of the shaded portion of the figure. We are in the business of finding area of shaded portions. All these selected questions are the questions you cannot run away from in your external examinations, even internal. WAEC, they knows about these questions. And as you are paying attention to them, you are going to deal with WAEC when the time comes. I bet you. Now, the only way we can find the area of the shaded portion here is by finding the area of the square. You know that if this side is 7 cm and this side is 7 cm, that means this is a square. If you find the area of the square, you subtract the area of this sector, whose angle is 90, times 4. 1, 2, 3, 4. That means area of the square minus 4 times area of one of the sectors. We give you the area of the shaded portion. Let me write it down. Area of shaded portion is going to be equal to area of square minus 4 times 4 into area of sector. So that is what we are going to work on now. So area of this square will be 7 times 7. Then minus 4 into theta over 360 times pi r squared. That will give us the value we are looking for. 7 times 7 is 49. We don't need the calculator for that one. So we have 49 minus 4 into the area of the sector. Theta in that perspective, in that question, or in that sector, means 90. Because look at the angles of the sector. So we have 90 all over 360 times theta is 22 all over 7 times. Then the radius of the sector, or the circle the sector is part of, is going to be half of 7 cm. You can see that they are halfways. And half of 7 is 3.5. So it is 3.5 squared that we are going to take. Okay? We still return our 49 minus 4 into. This fraction is something as 1 all over 4. That is 90 all over 360. Times, let's find 3.5 squared. 3.5 times 3.5 is giving us 12.25, then times 22. So what we are going to have in the numerator here is 2695. Sorry, 269.5. Then all over 7 times 1 is 7. What we're going to have is to calculate the radius of a circle whose area is 6.16 centimeters squared. The only thing we needed to be able to calculate the area of any circle on Earth is the radius. Once we can find the radius, we don't even need any diagram. We can calculate the area of the circle. So the formula for finding the area of a circle is pi r squared. And this pi r squared, they told us that the value is 6.16 centimeters squared. So therefore, when in this equation now we can find r, which the equation says we should find. Pi is 22 over 7 times r squared, which the equation is requesting from us, is equal to 6.16 all over 1. Multiply 22 and r squared, you have 22 r squared all over 7 is equal to 6.16 all over 1. You are free to cross multiply now. 22 r squared times 1 will give you 22 r squared, and it's going to be equal to, let's multiply straight, 7 and 6.16. 6.16 times 7 is giving me 43.12. Divide both sides by 22. You'll be left with only r squared on the left hand side of the equation. So we're going to have r squared is equal to 43.12 divided by 22. Just divide this by 22. R squared, I could get the division of 43.12 by 22 to be 1.96. Find the square root of both sides. Square root of r squared is r. Then find the square root of 1.96. Square root of 1.96 is giving me 1.4. That means the radius of that circle, whose area is 6.16, is 1.4. 2 golden circular medals, the one they won maybe at the end of every African Cup of Nations, or maybe even the World Cup. Of red dye. Red dye is the plural of radius. 3 cm and 4 cm each. We are melted. Yes, you can melt and remold a gold. That one is certain. We are melted and used to cast another golden medal of same thickness. So we are asked to calculate the radius of the new medal. 2 medals melted and used to cast another one medal. the area of the two medals is equal to the area of the new medal. Did you get that sense? Area of new medal is equal to area of first medal plus area of second medal plus area of second medal. That is the truth. That means area of the two metals that were melted, if you add them together, you get the area of the new one they were cast into, as long as they have the same thickness. Now, area of first metal is given by pi r squared plus area of second metal, the same pi r squared, will give us area of new metal, which is also pi r squared. That is true. Pi has a standard value, 27 all over 7, 22 all over 7, sorry, times the radius of the first metal from the equation is 3. So we have 3 squared all over 1 plus pi in the second area, 22 all over 7 times the radius of the second metal is 4. So we have 4 squared all over 1 is equal to pi in the new metal, 22 all over 7 times the r squared, which we are looking for. What you have here now is 22 times 3 squared is 9 all over 7 plus 22 times 16, 4 squared is 16 all over 7 is equal to 22 r squared, 22 times r squared all over 7. Let's find 22 times 9. 22 times 9 is giving me 198. So we have 198 all over 7 plus 22 times 16. 22 times 16 is giving me 352 all over 7. It's going to be equal to 22 r squared all over 7. Find the LCM. LCM of 7 and 7 is 7. 7 divided 7 is 1. 1 times 198 will give you 198 plus 7 divided 7 is 1. 1 times 352 will give you 352. And is equal to 22 r squared all over 7. At this level, add 198 and 352. 352 plus 198. Giving me 550 all over 7 is equal to 22 r squared all over 7. You can cross multiply here. If you cross multiply, you're going to have 7 times 22. 7 times 22 r squared will give you 7 times 22. 154 r squared. Will now be equal to 7 times 550. 7 times 550 is giving me 3,850. 3,850. I am going to continue here because of space. Sorry for that. We are going to divide both sides by 154 so as to have only r squared in the left hand side of the equation. So we are going to have r squared is equal to 3850 divided by 154. 3850 divided by 154 is giving me 25. So r squared is equal to 25. Now find the LCM, the square root of both sides. Square root of r squared is r, and square root of 25. That means our r boils down to 5 centimeters. And that answers that question. Remember, what you have here is plus area of second medal. This is medal, not metal. Now I want us to discuss the application of the principles of area in our homes and offices. And that was why you saw me writing application of areas at home and offices. The first question I want us to take in that issue is this question. They say calculate the number of tiles. Tilers always you do this kind of a thing whenever they want to give you quotation for a number of tiles that will be enough for a place you want them to tile. So the question said we should calculate the number of tiles, each measuring 30 cm by 30 cm. That will be enough to floor a room, a sitting room, measuring 6 meters by 4.2 meters. First of all, what you're going to do is you're going to change the measurements or the size of the tiles to be in the same unit with the room you want to tile. They gave the tiles to be 30 cm by 30 cm, and they gave the room to be 6 meters by 4.2 meters. You either change 6 meters by 4.2 meters to centimeters, or change 30 centimeters by 30 centimeters into meters. So let's adopt changing 30 centimeters by 30 centimeters into meters. And you know that 100 centimeters makes 1 meter. Therefore, if 100 centimeters will give you 1 meter, that means 30 centimeters is going to be 30 divided by 100. And if you divide 30 by 100, you're going to have 0.3. Just move the full stop that is here towards the left twice across 0 and 3 because of 2 zeros of 100. So 30 centimeters is the same thing as 0.3 meters. That means the measurement of the tiles, or like the area of one piece of tile, is now equal to 0.3 times 0.3, and it's going to give us 0.09. You can use a calculator and confirm it. That means one tile has area of 0.9 meters. Now let's find the area of the room. They said that the room measures 6 by 4.4. That means area of room. Area of room, because of space, will be equal to 6 times 4.2. 6 times 4.2 is giving me 25.2. Remember, this is meter squared, and this is meter squared. Now, this is the area of one tile, and this is the area of the room you want to tile. The number of tiles that will be required to tile this room will be the area of the room divided by the area of one tile. And it's